assessment asks us to predict how many signals we would expect in the carbon NMR for this particular structure. If we start on the left and work our way to the right, we start with the methyl group on the left side of the molecule. The methyl group on the left side of the molecule is unique. It is not equivalent to any other methyl groups in the molecule, and so therefore it would be represented by its own carbon NMR signal. The CH2 group next to it would be represented by its own NMR signal. It's different than the next CH2 group over. They are different distances from the oxygen, so they are different chemical environments, so they would be represented by different carbon NMR signals. The next carbon is the carbonyl carbon. It doesn't have any hydrogens of its own, but it is a carbon atom, and so it would be represented by a signal in the carbon NMR. Next, we have the CH group. There's only one CH group in the molecule, so it would be represented by a signal in the carbon NMR. And finally, the two methyl groups are equivalent to each other. If we rotate around the DE bond, we would see that these two methyl groups are equivalent to each other, so they would be represented together by the same one signal. So we would get one signal for the two methyl groups in the molecule. That tells us that there are 6 signals in this carbon NMR spectrum for this particular molecule.